All right, now we're gonna move forward and talk about the basics of the HVAC and what that means and how we apply that to the units that you see in this facility. So the very first thing let's talk about is, what does HVAC stand for? I know you've got handouts you can look at, but it's basically heating, ventilation, and air conditioning, or HVAC. Sometimes you might hear someone throwing out HVACR, but that's HVAC and refrigeration.
Mhm.
But we're talking about HVAC in here as a rule, or products. And it's the use of various technologies to control the temperature, humidity, and purity of air in an enclosed space. We don't just say it's an air conditioner and, well, what's that really mean? If you're only worried about cooling the air, you put a bucket of ice out there and blow a fan across it, you're going to cool the air. You're not going to control humidity. You're not going to do any temperature or not temperature control. No filtration. So this is all these things taken into account. That's our HVAC that we're worried about of air control and purification. So we, as of yesterday, if I came down here and saw this temperature you have, what causes temperature to rise in the space? Well, the biggest things we know right now is that the simple thing you have to remember, heat energy always flows from high energy level, hot, to low energy level. Actually, this is a law we have to remember about this. Can't break the law. It's the second law of thermodynamics. It states that when two substances are in contact, heat will always flow from the warmer to the cold. That's just how things work. You can't change that. That's how it's going to be. So energy is quantified, but we talked about BTU, the British thermal unit, and 1 BTU is the amount, important number to remember. Get into this, talk about it over and over. It's the amount of energy needed to raise 1 pound of water, 1 degree Fahrenheit. That's based at sea level conditions, because sea level and air in Denver, Colorado was different because of the properties. And you get real cold air up in Arctic Circle, that's a different thing. But the basis is at sea level. 1 pound of water, 1 degree. That's a BTU. So bringing in today's building, where are we getting the basis heat from? The thing is pretty obvious based on the temperature you had yesterday. It's item number 1 right there. Heat from outside through the walls, glass, roof, infiltration. We're getting a lot of hot air into the space. Besides everything I'm throwing out at you for hot air. Anyway, the big load. Add on top of this, electrical devices, computers, everything.
Lights.
Lighting, there you go. You got half of them off, thank Kevin, but all the lights, 3.4 BTU per hour per watt. So again, 60-watt bulb, 60 times 3.4, that's how many BTU that would give on that one component. Every computer we're running, every fan we're running, et cetera, adds that extra load. Right here, people, another big one. 450 to 500 BTU per person if you're just sitting at a desk. So,
But you never thought about that, did you?
how many people we have in the room? 24 people then, or
At least 20, yeah, maybe a little bit more.
24 times 500 is a ton of cooling we need just for the people sitting in here. Other load at all, but just that load itself. Then you take that into account of electrical devices, the infiltration. Now, if you're active, you're out in the shop or whatever, you're putting up to 700 BT per. So think what it would be if someone trying to figure out the load for a Planet Fitness workout center. How many people are going to be in there? How active they're going to be? That's going to be a pretty good load right there. They have to take into account. So all these pieces added together give us the building cooling load that we have to offset. Comfortable in this space. So what's the many ways we can do that? Well, we can throw that with the very basic, what if we just open windows? Well, and 107, that's not gonna do you much good. Maybe in mild conditions, that might help a little bit, but that's not the key today. The room air conditioner, I think you all remember the window units that we used to put in there, and they would, a complete unit. It was the heat cooling, discharge on the outside of the window, the air handler to blow the air in, all in one box. It got the job done for that little space, but it was kind of awkward, had to take up a window or a big opening in the wall, whatever. But if you want to cool that one space, it'll accomplish it. But now they've got the mini split system. Really, it's like a room air conditioner, but this is split in two pieces now. You don't have to have that big opening in the wall. You got the fan and the cooling coil on the inside. All you do is run the lines through the walls to a lot smaller openings. And then you've got a outside section outside, like a regular residential heater or cooling. So that's a mini split. The only size for the one space is not a ducted system. It's only do that one space again, but it can handle that area. Or newer ones now, a multi-split. They have the same air handler on the inside, but they might have more, let's say 5 of them. But one condenser outside. So one condenser can handle, say, 5 room ones. So again, that's only a room by room by room. There's no ductwork on these. These are just a small room or a small space that you're conditioning. Or you can get to the larger system with the use of air handling unit, where you have fan, coil, or whatever it might be. And we're going to concentrate on that because that's what we're going to see here in the Mestec plant is this type of equipment as a rule. So let's look at that. Here would be a typical, let's say this is a rooftop unit sitting up there on the roof. They got a condensed unit that's either sitting beside it or down on the ground level or whatever it might be. That is, an air handler is a device used to create conditioned air and move that air throughout the space. That's what we're trying to accomplish with an air handler. So number one, what the air handler is made to do, I tell you exactly where it is in this room, whether it's in the ceiling or through the hallway. We're pulling the air out of this space. And it's going up to the air handler. So it might be through the hallway, it might be through these, part of these, I can't remember which one's which anymore. But we have to pull it from the space. And it goes into the beginning of our air handler unit. Then we might also bring in some outside air because of the CO2 levels of the space. And that has to be taken into account with our people load. The more people we have, the more CO2 we have to be able to offset. So with that, you might have outside dampers, and we're bringing in a controlled amount of outside air to mix with this, so we can have the return air, enough outside air to offset our CO2 that we're concerned about. Again, pull back into the return of the unit, may or may not have some outside air brought in. With a high people load, this is almost a must, but take that into account.
So the air damper is equivalent to intake.
Well, it might be more like a mixing damper, so we can control how much air compared to return air it is. There probably, if it's a high amount of outside air, there would be an intake damper on that somewhere, excuse me, intake hood on that somewhere.
Yeah.
So that part is true, yes. Because we don't want to have rain and snow blowing into it. So there's some sort of an intake hood with the damper as well. The damper might be used so we can control how much we're bringing in. And maybe at night, you might have controls that turn the damper off and have nothing but return air because you don't have any people in here.
Yeah.
So just controls we can tie into that. Does that make sense? What I'm?
Yeah.
Thank you. Yeah, thank you. Once we get past that, then we're gonna put it over a filtration system. And this is all based on the application, you know. In this building here, you might get away with a MERV 7, MERV 10 maybe. You go into a, say we're in a hospital, we have to, well, the MERV rating has to be much higher in that application because of what they're doing. So, but we can, and then filter the air and air coil in, which we're going to get into next. First of all, it's clean, it's going to keep the coil clean, but it's going to meet the requirements of your application. You have to be aware of what you're trying to do at that point.
All outside air typically has some dirt particles too. And return air that also has some dirt particles too.
That's right. So now we're going to pass the air over a cooling coil. Example here, that's a DX system. Pass the air cooling coil to lower the temperature, and also when it lowers the temperature, then dehumidify the air. You're going to get some of the moisture out of it. At the high comfort level, as Doug said, we have a lower temperature. Keep in mind again that a cooling coil is a form of a heat exchanger. The transfer energy from one source to another. So that is a heat exchanger that we are taking into account. Of the blower in there, move the air throughout the air handler and all the ductwork. And key thing to remember on this, and that makes sense when you think about it, it's often referred to as the heart of the air handler. Well, it's like the heart we have. It's pumping the air through the complete system. So that's the heart of the air handler system. That's what's moving the air from point A to point B over and over again. So a very important component, obviously. If that blower goes down, your unit's done.
You're not moving any air, and when you're not moving any air, nobody's coming.
Now, if, for example, we want to heat in this space too, if you had an indirect fired heater, and I know I have a cartoon here, just an open flame, an indirect fired heater, it would be located on this side of the blower, the pressure side of the blower where it's typically mounted. I just wanted to show it where that would be if you did have heat that you needed as well. I don't think you need it today, but that's something to consider. But once you go through that, you plug it into the unit, you might bring in some outside air, you've filtered it, you've cooled it down, you're still pumping the air, you may have heated it if you need to. Now we're going to put it back into the space. And so it comes back into space again, and it's just going to start the whole process over and over. And that's how we maintain a temperature in any enclosed space over and over again. So just these little BTUs going from here to here, exhaust out because of the coil, and come back and pick up some more of those BTUs and take it through the system again, over and over again. That's our basic air handler and how they work. And the basic components you're going to see. All right. There is a test now, as we said. Good news is, this is what I'm going to call an open book test. In other words, all the notes you've taken or whatever, you can refer to. The bad news is, so everyone get a piece of paper here for your test. Put your name on there because we have to have everyone's name on it.
We're gonna know who's testing it.
I don't want to have a bad. Once we get started, after we get our name on there, you know when we're ready, we're gonna have 10 minutes to do 5 questions. Their name on it. All right, I'm gonna have to start. Go ahead and start your test.